Okay, let's try an example of the shells method. Let's find the volume of the solid of rotation formed by rotating the area bounded by y equals x cubed minus 6x squared plus 8x plus 5, y equals 0, also known as the x-axis, x equals 1 and x equals 4, around the y-axis. Why did I come up with this graph? For two reasons. First of all, I have a vague idea what it looks like. It's a standard equation of degree 3, which means it's got the goes up, it bumps, it comes down, it bumps, it goes up again. And I have some sort of clue as to how to graph this. There it is. I'm not saying it's 100% accurate. Here is the area that we want to rotate. It's going to come 1, 2, 3, 4. It's going to go something like this. And what does it do? Like that. We're going to get some sort of object that looks like this. Again, it's not different, too different from this car part thing that I'm always thinking about. But the main point is, if you tried switching the x's and y's in this and you wanted to solve for y, it's basically like solving for x in this equation. I wouldn't be able to do it. That's just a nightmare. Maybe a computer could do it. Actually, yes, a computer can do it. It can be done. There is a formula for solving cubics. It is gross. It is about 5 to 8 times bigger than the quadratic formula, which is a lot of people find this unpleasant. No, we can. But if we to use it in slices would be a pain in the butt. No, use the formula for the shells method. V is the integral from a to b of, what is it, 2 pi 2 pi x f of x dx, which in this case would be the integral from 1, 2, 3 up to 4 of 2 pi x times the function, which is x cubed minus 6x squared plus 8x plus 5 dx, which would see, we can put the 2 pi out front, integral from 1 to 4, we can multiply the x in, x to the 4th minus 6x cubed plus 8x squared plus 5x dx. And what have we got? We're still doing calculus here. We get x to the 5th over 5 minus 6x to the 4th over 4 minus 8x cubed over 3 plus 5x squared over 2. And we plug in 1 and 4. And at this point, it stops being calculus. It becomes a very, very tedious arithmetic thing. I mean what? I plug in 4, I plug in 1, I subtract. That will give us the answer. And we have a number. It will be a pain. We can put it into a calculator. But this is the power of this method, the shells method. And that's enough for this video.